Lyons and the emergence of business computing. Leo computers were a series of machines designed, developed, and manufactured for business applications between 1947 and 1968 by the British catering firm Lyons Co and its subsidiary Leo Computers Limited. And this presentation takes the Leo computers as a case study for understanding the emergence of business computing, aiming to analyze both how the introduction of computers affected commercial enterprises and how computer design changed because of the new requirements of business data processing. So, this first slide is to give you an idea of the timeline of events we are talking about today. So we're starting from 1894 with the establishment of Lyons Co in London until the final merger in 1968 and the formation of International Computers Limited. So Lyons Co, I'm sure many of you already heard about them or remember their pack tea and cocoa or biscuit, was established as a big events catering service and tea shop company in 1894. The company grew through the early 20th century, and by 1939, Lyons had 253 shops and more than 20 restaurants and corner houses across the whole UK, and employed more than 30,000 employees, and was also a manufacturer of tea, coffee, bread, cakes, ice cream, and frozen foods. And Lyons supplied thousands of retail shops directly. So from tea shops to computers. So how did it happen that a company of catering events and tea shops became a manufacturer of computers? So the evolution of Lyons subsidiary Leo Computers Limited cannot be understood without taking a closer look at the history, structure, and philosophy of the parent company, Lyons. By analyzing some of the main patterns in Lyons entrepreneurship, it is possible to understand why the establishment of a computer company fitted within the firm's vision. These patterns are their continuous search for improvement to their business, their philosophy of vertical integration, their reliance on the principles of scientific management, and their adoption of organization and methods procedures. These were all key factors for their decision to enter the computer business. So yes, Lyons followed the philosophy of vertical integration, and the whole food production was covered, from packaging, printing, laundry, vehicles for deliveries, and also the repair. Tea shop and restaurants had to be comfortable and affordable. So Lyons had small margins, and their business required careful recording and analysis of each transaction to achieve profits. In particular, in the 1920s, Lyons felt that the one way to improve the efficiency of their business was to employ managers with an academic and scientific background. For this purpose, they hired a Cambridge mathematician and statistician, John Richardson Mainwaring Simmons. When John Simmons joined Lyons, it was 1923, and he noticed that the checking department, which took care of the adding up and the controlling of millions of waitress bills, had some kind of need. So in an interview to Christopher events in the 1970s, he declared, there were some 300 women eventually doing nothing but adding up and checking the adding up of waitresses' bills. It cried out for some kind of automatic machine to take over this work, which was not fit for human beings to undertake. And then he adds, paradoxically, by the end of the war, Second World War, in 1947, all the waitresses had disappeared. So the real need for the computer for that kind of job had also disappeared, but it was in our blood. So, as I mentioned, Lyons followed the principles of scientific management and organization and methods, and in particular, the work and research of Taylor, the Gilbreths, Bedeau, and Mogensen. Organization and methods is a systematic examination of an organization's structures, procedures, and methods management and control from the lowest level to the highest. And in particular, the time and motion studies and process charts that were developed by Taylor and the Gilbreths were also used in Leo computers. Not just in Lyons, but also later in Leo computers. One example that predates the Leo computer is the wholesale bakery sales invoicing study that was developed in 1935. So when we are talking about this, we are talking about invoicing. So instead of producing several copies of the client's orders, which was invoice, delivery note, packing note, and so on, the customer's order itself was turned into the invoice, adding the price of each item and the total. And then the order invoice was sent back to the customer, but only after taking a picture of it through the use of this recorded photographic system. So this shows also how Lyons were using a kind of archiving system that was really taking pictures and storing this picture instead of the paper receipt. So this is really like interesting in this respect that it was in some sense already thinking about data management in a more modern way. So when I interviewed in 2019 data entry operator Caitlin Keane, I found very interesting that time and motion studies practices were inherited in the Leo computers, and in particular, she told me we had to measure how much we punched and how long it took. And I think what they were doing probably was trying to decide how many people they would actually need to punch certain amounts of data in the future when they had a lot of stuff to do. And she, ironically, she was joking, but we were bright girls and we were very fast. So I don't know if they always managed to attain that sort of speed. But this is really something that is really how the organization and methods procedures were kept also into the Lyons computer, and they were applied to every part of the design of the process. So in 1947, Lyons decided to send 2 senior employees to the US in a fact-finding trip to study developments in offices, but also in computers and catering. So we have to think that after Second World War, they were trying to redesign their business, and they were sending these 2 senior employees to see what were the new developments in the US. And they were, one of the purposes was also to see what was happening in terms of what were called electronic brains. But we have to also think and keep in mind that no commercial computer was available on the market in 1947. And during the trip in the US, the Lyons employees discovered that was actually an advanced computer project that was in the UK and not, and so it was close home, so in Cambridge. And so as they got back in the UK, they established a contact with Maurice Wilkes at Cambridge University that was developing the EDSAC computer. And they formed a partnership with the University of Cambridge. And after evaluating several possibilities, they decided that the option of building a machine in-house with the collaboration of Cambridge University was the best option for them. So they sponsored the final stages of the EDSAC computer development, and with the agreement that if EDSAC worked, Cambridge would help Lyons to build their own business computer. And when, in particular, in 1949, EDSAC work, that was really an important moment for the company. So to understand the differences of these two machines, EDSAC and the re-engineered version, Leo, Lyons Electronic Office. So EDSAC was the machine produced by Cambridge University, and Leo 1, initially only Leo. We also have to understand what were the different requirements and what were the different environments these two machines had to work in. So the EDSAC computer was a computer thought for the use of the university. So for the researchers of the university. So the EDSAC had a multiplicity of users, not always as skilled programmers, and they had to run complex one-off mathematical computations. But the requirements of the Lyons computer, of Leo, were different, because they had to have a number of large dedicated programs and by a large number of skilled programmers. So data entry was time-consuming, while calculations were simple, as opposed to the EDSAC and the scientific computing. And in particular, for each application, a large program or a set of programs had to be run repeatedly, once for each transaction of batch of data. So really, we have these two different requirements of computing. The university and the commercial, the business kind of calculations. So at Lyons, they decided they shouldn't wait for the EDSAC to be running to start developing their own computers. So basically what they decided to do was to proceed in parallel. So system design and program development proceeded in parallel with the physical construction. And so the decision was made to use the EDSAC design as the agreement with Cambridge University. And they chose to copy the EDSAC with no changes until they understood why each solution had been chosen. And so they started to think about which kind of programs or application they could be using to test, to try and see what were the requirements of this machine. And there were several applications suggested: sales invoicing, inventory management, payrolls, pay as you earn. And then the idea was to try and test a payroll. So in the end of 1947, right after the agreements with Cambridge University, an employee of Lyons Organization and Methods Department, Derek Hemy, began the study of the clerical application, so a payroll, to be tested on the ETSAC. And in May 1948, Hemy goes to Cambridge to study programming, and he codes and he starts to plan the payroll and coded it in collaboration with David Wheeler at Cambridge University. And in exchange, also Wheeler spent the summer of 1948 at Lyons in the Organization and Method Department, working on programming techniques and methods for program input. So in this phase of the development of the ETSAC and Leo, there is really a strong connection between the two projects. So why a payroll? Payroll was chosen because the results could be checked in detail against the results manually produced by Lyons Wages Office. So there could be a comparison. Lyons could establish which clerical savings could be made by using the computer by this confrontation. And payrolls also had specific time requirements, from the availability of data to the deadline for pay slips. And there was a weekly time cycle, which was very, very, very important, and also is one of the main differences between what was the kind of calculation they had to do at university and what kind of calculation were needed for business computing. So in his book, Leon the Managers, Simmons in 1963 wrote, "The mathematicians were not very concerned about getting their calculations done on a given day or even in a given week. Without an automatic computer, they might never have got them done at all. In clerical work, however, we needed to get the work done on a given time, so it was essential that we could rely on the machine." So, and also, Leo 1 was quite able to undertake mathematical problems, while the then mathematical computers were either not able to undertake commercial routines or could not undertake them economically. So programs for clerical or office job tended to be much bigger, and there were two main reasons for this. First, once the data was loaded in memory, it was more economical to carry out as many operations as possible on it. So the program would then be written to cover a series of interrelated routines rather than just one, making it longer. But the requirements of such jobs were less logically structured than the mathematical ones. So the complexity was originating in commercial and legal regulations, which led to many possible variations and anomalies. So Hemy's test program indicated the necessity to double the size of ETSAC memory from 32 to 64 Mercury delay lines, and to revise and speed up the input-output peripherals. So there were 3 input channels: permanent data brought forward from previous week, and new data applying to the present week only. And so there were the kind of inputs, media were punch cards, traditionally punched, punch cards where the data was held in binary card rows, and paper tapes. And they used Hollerith punch card readers and Ferranti fast punch tape readers. And the output devices were a line printer and BTM card punches. They also experimented in between 1952, 1953 with magnetic tape decks that were designed by Standard Telephone and Cables, but they never worked. So at some point they thought about magnetic tape very early, but then they had to not continue. So one of the things and the methods that were used to design programs were the flowcharts. So the ETSAC basically almost never used flowcharts to manage their programs. The EDSAC had a library of subroutines for mathematical functions that were like held on tape, ready to be copied. It was a library. So this library was ready, so you could take the tape with the routine you wanted, and you could copy it and incorporate into user programs. Instead, for Leo, the program was started by the analysis of an application, and it was developed by creating a strategic master flowchart, and then programs were divided in a sequence of subroutines. So often there was a bigger master flowchart, and then there was a flowchart for each subroutine. Flowcharts in Leo are important. First, they were a well-managed discipline. As we have seen, they were very familiar with organization and methods techniques. They were also planning aid, but also, and this is very important, they were a tool to ensure program correctness. So each subroutine was tested in isolation and corrected before the whole program was subjected to trial. And so flowcharts and then code were carefully checked by different colleagues on paper. It was important, they had to be 2 different people at least. No punching was allowed until programs were signed off by a program checker. And debugging online was discouraged because of the scarcity and the cost of computer time. So program runs were divided into batches to allow restarts from local routines in case of failures. So, and this is a picture of Leo 1. So as I mentioned, Leo 1 had twice the memory of the size of the Cambridge computer, counting 64 mercury delay line tubes, 2048 bytes, 17-bit words. It included 21 racks containing 228 separate electronic units, each containing 25 thermionic bulbs. The electronic units were modular and standard size, and there were 12 per rack. Servicing and repairment was made easy by knurled finger nuts, and the whole machines had almost 6,000 vacuum tubes. The word size was 17 or 35 4-bit characters. Jobs were time critical and had to be completed to a rigorous time schedule, and available input-output mechanism at the time was low, and conversion from decimal and binary or Sterling notation and binary took usually up to 90% of the entire running time. The storage tubes were in a false floor, and the control desks included facilities to stop, start, run slow, to go into single-step mode. There were oscilloscope to look at the contents of the storage tubes. There were buttons to stack and store, and also engineering task controls. There was a loudspeaker. There was an interesting feature because if the loudspeaker were producing irregular noise, everything was considered to be fine. But if the computer was stuck, it would produce a continuous noise, repetitive noise. And that was also a way to understand what was going on with the machine. And, you know, it was useful to, it was a way to control that everything was going fine, or to understand what was not working. And the racks and the chassis were designed by Lyons Drawing Office, and they were made in Lyons Engineering Works at Acton. So after Leo 1, and on the 4th of November 1954, Leo Computers Limited is established. So it was always in the idea of Lyons to produce more than one machine, and in particular Leo 2 incorporated the design of Leo 1 with the logic circuitry made by thermionic and germanium diodes and hard valve amplifiers. And the memory consisted of 64 mercury delay line tubes, and each holding 16 long words or 32 short words. And the storage was 4 times faster than the Leo 1, and the magnetic drum as backing store was added. And the last 4 machines, so 11 Leo 2s were produced, but the last 4 were with core memory and a mixture of transistors and bulbs. Some DECA 3000 magnetic tapes were added as input-output devices. And it was established that Leo 2 could carry out the work of 200 clerks in this place usually occupied by 30. So Leo 3, the Leo 3 was developed, and the prototype became operational in 1961. The first Leo 3.1 was used as Lyons Internal Bureau, and it was installed in April 1962 at our treehouse, along with the working Leo 2/5. And the Leo 3 series belongs to what is usually considered the second generation of computers. The Leo 3 was fully transistorized and had a magnetic core store and an operating system called the master routine. It included multi-programming and also a micro-programmed order code. And Leo 3 comprised a range of computers that were compatible. Leo 3 standard, Leo 326, and Leo 360. They had identical instruction codes and interchangeable programs. Routine and program trial aids could be used. But what changed in the Leo 326 and 360 was the fact that the arithmetic unit and coordinator were logically redesigned to take full advantage of the high store electronic switching and the shorter store access, resulting in action times faster than Leo 3 standard. And so the basic unit of storage was a division of 4,096 words, housed in a single cabinet, where the magnetic core memory was allocated in the top of the cabinet and thermostatically controlled. Up to 4 cabinets could be connected to form a store of 16,000 words. To obtain a greater storage capacity, up to 4 store access control units were required, bringing the total maximum storage up to 65,000 21-bit words. And so more than 60 Leo 3s were produced, 37 Leo 3 standard, 7 Leo 360, and 17 Leo 326. And they were sold in 3 continents, 52 in the UK, 3 in Czechoslovakia, 2 in South Africa, and 4 in Australia. And there was also 1 in Wales, the Leo 344, 326, at the National Data Processing section of the GPO in Cardiff, and was working from 1966 to 1981. So what I'm going to do now is I'm going to continue the description of what happened to the Leo computers through a case study I researched. And this is, so we arrived to the establishment of, the production of Leo 3. It starts in 1962. And in 1962, exactly, Lyons Leo computers faces what many other European computer companies are facing. All these companies had financial issues because they had to invest a lot in producing this new computer and in researching them, and a lot of pressure from the US competitors. So I published this bit of research in a paper on the IEEE Annals of the History of Computing in 2019. And I studied the way some European computer manufacturers tried to react to these perceived American takeover of the computer market in Europe. And I presented this as a case of Europeanization, a strategy of defense against the American takeover of the computer market, opposed to the paradigm of Americanization, which is the adaptation by other countries of corporate values, technologies, and symbols from the US. So in July 1962, Lyons were advised by their mentioned Barkens Lazar brothers to try and figure out a way to merge with other computer companies. They had talks not only with Leo, but also with English Electric. And what they suggested was that Leo was too small company compared to IBM or even ICT. And they should consider to link up with English Electric and perhaps also a third or fourth company. And so while trying to organize these agreements between English Electric and Leo, they also tried to expand and they looked at our other European computer companies. And in particular, they chose Olivetti in Italy for their sales expertise because they had the European and worldwide sales organization, having Olivetti taken over Underwood in the US. So they had the whole network of Underwood in the US. So what happened was that there were negotiations. First, there were meetings with Olivetti, English Electric, and Leo, and they had discussions. In particular, I researched archival material on these. The discussion was like, so what Olivetti could offer English Electric: input and output peripherals, parallel serial printers, magnetic tape units, converters, but they were not interested in selling English Electric computers. What Leo could offer Olivetti? Leo 3 and the English Electric computers, because they were of the different range, because Olivetti computers were of the smallest range. The UK market contacts for smaller and cheaper computers, so they could be, Leo and English Electric computers could be sold in Italy, and in exchange, the small Olivetti computers could be sold in the UK, but also the sales potentials in South Africa and Australia, as we have seen. Leo was selling also in other countries abroad. So eventually, these network and these negotiations with computer companies in Europe expanded, and there were like English Electric, Leo, Olivetti, Siemens in Germany, and Compagnie des Machines Boulle in France. And they have several meetings and exchanges, and they try to create a possible plan for a consortium of European companies. And there were like each company had, their own. They would divide, different size and also role. So for sales and user research, Boulle in France was for large computer, medium computers Leo, small computers Olivetti, but the research also Leo. Accounting machines were produced by Olivetti, punch cards, Boulle, and for production, maintenance, and production research, large computers Boulle, medium computers English Electric and Siemens, and so on, as you can read. But eventually, these agreements failed. At some point, they even give a name to this possible partnership, that is Eurodata. Why did this partnership fails? First, different corporate cultures, research policies, product development and marketing, but also different size of business and areas of interest in the computer market. This was a fragmented industry, and it was still distrustful towards domestic and international competitors. So they really were distrustful. So they couldn't really agree in joining forces with what they really saw as competitors. And there was also a tension between a nationalistic industry protection and the appealing idea of a transnational cooperation inspired by the newly establishment of the European Economic Community. So, but there were also issues of compatibility between products, peripherals, software, and programming languages. In particular, these companies underestimated the importance of software and application, and this was never a topic during negotiation. So the European Common Market, from which the UK was repeatedly excluded by French vetoes until 1973, and the related antitrust issues caused more problems and opportunities. And paradoxically, IBM and the other US firms could profit better from the European Common Market than the European firms themselves. So eventually, these agreements, they don't happen. And there is a first merger between English Electric and Leo in 1963, another one, English Electric Leo Marconi 1964, and finally all these British computer manufacturers would be merged into International Computers Limited in 1968. So just to give you little flavor of what happened also to Lyons. So we left Lyons with some financial problems caused by the subsidiary Leo Computers in 1962, 3, 4. So also the tea shops and Oxford corner houses and hotels and all the big economic system they built was going into having some difficulties. And so Lyons try to reinvent the offer they have for their clients. And in particular, I found this project that it's very interesting. So to overcome the crisis in their main food business, they asked an architect, Cedric Price, to rethink the customer experience of the restaurants in central London. So in particular, what Cedric Price designed in 1965-66 is a building that was supposed to be open 24 hours for communications, as a communication and learning center. The project was visionary. There were like floors that were moving, and it was conceived. And it's very interesting because what the word they use, information hive. So there were facilities for conferences, for teaching, for exhibition, but they even conceived the computer use for the public. So we are in 1965-66, and the project involves having some terminals to use IBM 360s for a general public, like, you know, it's like what we could think like an internet cafe we would like cyber cafe, we could think of many years later. And so it's also interesting because computers were there anyway. And sadly, or ironically, the computers were not Leo, they were IBM. So I'm going to stop here. I just would like to point out, if you want to discover more about Leo, there is the Leo Computer Society website, together with the Center for Computing History in Cambridge. They had recently a 3 years Heritage Lottery Fund project that was very, very, very good for preserving a lot of archival material, but also with the joint venture with the Center for Computer History in Cambridge, it also produced a virtual reality project of Leo 1. So if you go to the website, or the second link, you could download an app and you can experience the 3D version of the Leo 1. Then I'm going to also point out, like, if you want to know more about what I talked about today, there are my publications, my PhD thesis. I was supported by the Leo Computer Society for my PhD thesis on the Leo computers at Middlesex University, through the David Tresmat-Kaminer Scholarship for the History of Computing. And there is also a forthcoming paper that is going to be published this year about the influence of organization and methods on early business computing. That is going to be published on Amazon Press, and the editors are Arianna Borelli and Elena Durnova. Thank you very much for hosting me here today.
Right. So, shall I do the questions, Andy, or do you want to do the questions?
Do I want to do the question?
We can share the questions if you like, John. That's not a problem. Let me just pull up where my questions are.
We have one or two in the chat, I expect.
We do indeed. And it's still not too late to ask some questions as well. So if anything had sprung to mind while you were watching that, please feel free to drop it in the chat.
Can I ask a question first then? Elisabetta, I was struck by a remark you made about, I guess, the Leo 3, and namely that there were 3 different models, and
Yes.
that you expressed the idea that because they had a common core, programs were portable across the model range. Now, that's what I missed out with that. Would that be 1962 onwards?
Yes.
Right.
So the first prototype was working in 1961, and 1962 is where, actually 1962 is when it starts having regular.
But the reason it struck me is that one common thing that one talks about is the transition under Thomas Watson Jr. to the world of the IBM 360, where you have this interesting point about an accumulation of IBM machines, where in some sense or other, when you outgrew one machine and bought another one, it was a major task to get any software that formerly ran on one machine to run on the next. And I'm not sure where to read about why that is, but it might be variable word lengths in the older programs. It might be a whole bunch of things.
Okay.
But, so the IBM 360 is conceived around that time, but comes later, right?
It's I think it's announced in 1964.
Announced in 64. Okay,
Yes.
so that's it. So
Probably
Leo,
but this is, my memory, but yes, it
okay.
should be around those dates. Okay,
Oh,
so yes, so yes, the observation is interesting. So yes, what probably I have to clarify is that there were not completely entirely different machines. It was only some parts that were redesigned to be quicker.
okay.
So in some sense, there is the idea of compatibility, but in some sense, it was basically the machine, and that was redesigned. It was redesigned to make it quicker, to speed it up. But yes, but there is this idea of compatibility that it's important. And yes, you're right. IBM 360, 1964, 1965. Yeah.
Can I ask Andy to take over the questioning now at this point, Andy?
Yeah, certainly. Let me just switch my video. Ooh, back on. Okay, so we've a couple of questions in the chat. First one from Michael, and Michael has asked, have any Leo computers been preserved for the future?
Okay. Oh, yes. So there are. Now I am like, I had everything. Like I reconstructed a little bit that for my PhD. I'm not sure I will remember everything, but so there are. So the Leo one, I think, was even offered to the Science Museum when it was decommissioned. I think, I think that was 1965. Forgive me, I don't remember every date at by heart, but the Science Museum didn't take it, but there are parts of Leo 1. There are some Mercury delay lines and some others. There are some at Center for Computing History in Cambridge, but also at the I remember seeing some of those also at the museum warehouses in Birmingham. Then there are other parts spread around, and in particular, there is a Leo 3 machine. I think probably complete. I remember visiting it in 2017 or 18 at the National Museum of Scotland. So it was acquired by the National Museum of Scotland. And then I think it's pretty much complete. And then there are parts of Leo spread around. Probably, I'm sure the Leo Computer Society is doing these specifically as a project at the moment to check what are all the parts of Leo spread around. There are parts of Leo also in Australia at the Museum Victoria. And this is all I'm remembering now, but if you want, I have these bits of information at his, just gonna take my file, and I reconstructed as much as possible this for my PhD. This is at least what I'm remembering now, but there are parts of Leo. There are like core memories, there are others, Mercury delay lines. I'm sure that there are other people in the Leo Computer Society here in this talk that can help me to provide more bits of information. But I think that we have quite a good number of artifacts and a lot of documents. In particular, I have to say that the Leo Computer Society has been very, very active in the last few years to really collect as much as possible from the members and from former Lyons and Leo employees. And I remember,
very much. Well,
I mean, one of the most, I can add these at a bit of color. I remember going to a meeting of former Lyons employees, and that someone gave me a short mercury delay line still filled in with mercury in my hands out of nowhere in a pub. That was really like, that was one of the nicest and weirdest times of my PhD research. There was really like, you know, I didn't expect that. He didn't tell me that. And I had like this mercury delay line. You know, mercury is dangerous, you know, so you really shouldn't go, you know, on public transport with mercury tanks, right? So I was there like, and now what do I do? So, yeah.
wow.
Yeah.
That's incredible. Well, Michael, hopefully that answered your question. Thank you very much for that. Yeah, fascinating. Let me just look down the list if we've got any. We've got another question from Megan. And Megan has said, how much did developing Leo cost Lyons? Were you able to find any documents about their cost analysis prior to deciding to invest in the R&D?
Oh, yes, I had all these bits of information, but I don't remember now. What do you want me to check? I immediately remembered that, you know, I have these, even I have the memory of the document, right? I remember, no, I mean, really, like now it's, I mean, this is my big issue with talks. I should like just get I have these in my mind. I remember that it was a lot. It was a very big investment and was not compensated by. And that was what it was actually the starting point of the, you know, realizing how much it was costing. This development was exactly where it started from. We have to do something, we have to think of other alternatives or merging or partnerships and these kind of things. But I have to say that was calculated pretty much. I found, you know, I found some detailed charts about that. And I have to say that was not, you know, anything that had to do with anything that was, let me not say, I don't know if this is the right expression, but I mean, it was not Lyons' fault. It was not anyone's fault. Every company was in the same situation. Research and development was really costing a lot. It was every machine at the time, every model, you know, was not was developed in some kind of like we can say something that was crafted in some sense. It was not an industrial production as we might think of today. I have the example of the Compagnie des Machines Beau, and Compagnie des Machines Beau. One might think, you know, you have new orders for a machine, and that is something good, right? You've got new order. This means the company is going to do well. But because these machines were typically leased instead of being sold, to have a new order basically meant that the company had to invest in the production more money, and the return of this investment would be in the next 10 years, perhaps. So basically, to get more orders was not something good for the company, was what was creating even more damage to the financial situation. So it was in some sense not sustainable. And that's basically, what happened was like, companies merged or were bought. So we have the example of Olivetti and Boo that were bought by General Electric from the US in 1964-65. So this was kind of a common situation. But when I say that, paradoxically, it was IBM and the other US competitors that benefited from the European market, it was really because they could manufacture several parts in several countries and then assemble them together. It was really something that was also another paradoxes of these moments in the European computer history.
Thank you for that. Brilliant. There are a few comments to say thank you. A few of our guests saying, fascinating, wonderful presentation this evening. Jeremy has said that thank you for filling in some of the gaps in his own history, as his grandfather was actually a manager of a Lyons Corner house during the introduction of the Leo systems. So that sounds like that was really nice for him to hear that. Just scrolling through, we've also Tom Brooks has said greetings to yourself, Hilary and Vince. I joined Leo in 1962 after using an IBM Cadet in Swansea University. Having the post office as a customer was very important for Leo and the UK computer industry at large. And then it also included the telephone company and the preeminent bank PO Savings. Leo trained the UK workforce on large-scale project development, project management, and maintenance. And then he's finished that with a question. Are there still any former GPO Cardiff LEO staff in the branch? So if you are a former GPO Cardiff LEO staff, please put something in the chat. And if you're watching this back, why not send us an email and we'll connect you all. That would be lovely as well. Is there anyone in the room that is a former member of Cardiff LEO staff? That would be incredible.
Yes, it would be. I mean, that would be also one of my last questions here. I had that in mind, but I know it's very interesting how much former Leo employees are very passionate about Lyons and Leo, and that's incredible. And these, I think, there is a recognition of what was what they were doing. They were conscious of the fact that what they were doing was pioneeristic in a way, and that's what creates also some kind of very, very nice emotional attachment to these machines. And I'm really, really, really happy because I received an invaluable support from the Leo Computer Society, from former Leo employees. I managed to interview many, many people for my PhD, also traveled a little bit across the UK, but it's really interesting that a lot of the memorabilia came from what people kept. Because, and if you keep something from your workplace, this means that you really acknowledge what you're doing, and what you're doing is important. I remember someone who still had the first payslip. I remember, I had really, I really managed to see a lot of, not just, technology production, not technological parts, like, but from bulbs to core memories or whatever. I mean, mercury delay lines, right? But really also even other things like, the invitation to a luncheon, or, everything was kept because it was important. And this is very interesting. You don't keep it if you're not in a very nice environment where you work.
Absolutely. Right, I've got Hilary is one of our guests and would like to say a few words if they can, because they were, Hilary, you said you saw Leo as a young child. Your father was one of the pioneers. So let me just try and unmute. If you try and unmute your mic, that should work.
Yes, does that work?
It does indeed. Hi, Hilary.
Yeah, hi, lovely to be here. I just wanted to say, I thought that was, I'm so pleased that Elisabetta's now talking to groups like yours, because I'm secretary actually of the Leo Computer Society. And the reason I'm secretary is because my father, Elisabetta got as far as some of the early pioneers, but my father did the initial systems design and led on the programming of Leo 1, working with John Pinkerton, who did all the hardware. And I just wanted to reinforce, actually, because you moved quite rapidly on, Elisabetta, from Leo 1 to Leo 2 and Leo 3. But just how exciting, you mentioned the payroll, but Leo 1 couldn't actually start with the payroll. They wanted to get it out in a rush. And they were the first to get theirs out. And in fact, the Queen went to visit it in the February of 1951 before it was working. And when we had our 70th anniversary, she sent us a nice letter saying she remembered fondly her visit, which I doubt very much, but a lady in waiting put that in. You also said, Elisabetta, that in Europe, the successors to Leo were a bit eclipsed. But I do just want to point out that my father, as I say, who worked on Leo before it was even Leo, also led on the introduction of the major computer in Luxembourg for the EU, much later on, just coming up to 1980. So there was that continuity. But thank you very much, Elisabetta. It's lovely to hear you explaining it all so vividly to this lovely audience here. So thank you.
Thank you.
Thank you, Hilary. Elisabetta, are you okay to answer one more question? We've got one more question in the chat.
Absolutely.
Okay, this is from Benjamin, and Benjamin said, has there ever been an attempt to build an emulator for any of the Leo machines?
Yeah, so there are there are for the EDSAC, and yes, and David Holdsworth is active with the Leo Computer Society. So there are several projects of resurrecting the Leo. Yes, so yes, they are under development. There is also a recently established group on the Clio. So yes, we are working on that. Absolutely. I think there was also recently a Computer Conservation Society talk about this too. Yeah. John Dane involved in these, David Holdsworth, and many others. Yeah.
I mean, if there is anyone on the call this evening that is interested in sort of knowing a bit more, please do get in touch with us, and we can share some of that information. And I'm sure there'll be some additional links and things that we can share with people.
If that was really that would be my last remark. Say, any in the public was working with Leo, with Lyons, and please reach out to me, to the Leo Computer Society, and we'll be very happy to take your memories and also to survey bits, memorabilia, whatever, linked to the history of Leo.
Fantastic. There's been an incredible talk this evening. Just before I say a few, unless there's any other comments, anything else you want to put in the chat, we have got a couple more minutes before we have to close the webinar completely for this evening. So if you have got anything, please drop it in the chat now. John, did you want to say any more words before do a kind of final close for the group?
No, though I'd like to draw attention to the fact that the themes that we've seen tonight in this talk are really quite deep and quite long-standing and are very timely. Elisabetta mentioned, for example, the emergence of so-called scientific management, which is an extremely influential and important development of the 20th century that affected the way we organize so much of our manufacturing and our office life, which lays the foundations for this kind of computing. And I think she made the case beautifully of the way in which business data processing is data heavy. And that is something of great interest, I think, in a world that we live in now, where you can hardly lift a finger without someone measuring it, stick it in a computer and sending it via a satellite to the United States or China. So I must say, I think there's a lot of important principles and ideas that these pioneers encountered and used in developing this extraordinary machine. So I think we should bear that in mind, how alive this topic really is for contemporary consent.
Thank you.
Any final words from you, Elisabetta? Because obviously this has been your talk this evening. Anything else? Any final pearls of wisdom before we finish this evening? No?
No.
Okay. In that case, if you don't mind, I'm just going to share with everyone a few sort of contact details, so that if you do want to get in touch with the branch, you do want to know more about this evening's talk and the speaker, please do get in touch. A few final words, if you don't mind as well. Just say thank you to everyone who's joined us for our annual history lecture. Obviously, a huge thank you to Dr. Elisabetta Mori for the fabulous talk this evening, and of course to our host, Professor John Tucker, and to our Vice Chair, Paul Bulmer, for doing a lot of the arrangements in the background. I'm Andy Bellamy. I'm the chair of the South Wales branch. For those of you who don't normally come along to our webinars, we are the Chartered Institute for IT in the UK, better known as the British Computer Society, or BCS for short. We have over 70,000 members in over 150 countries across the world. We're a community of business leaders, educators, practitioners, policymakers, and all committed to the global BCS mission of making IT good for society. Our South Wales branch, largest branch in Wales and the second largest in the UK, actually, with just under 4,000 members. Amongst other community-based projects that we're involved in, we like to stream a live topical webinar like this every month. Members and non-members can register. You can join the live stream for free, as well as being able to watch it back on our dedicated branch YouTube channel. And we present on a huge, diverse range of topics from across the sector. If there's a particular topic that you're interested in and you'd like us to cover, or you're interested in presenting a webinar yourself, then please do get in touch. So really, just to wrap up, if you'd like to know more about our volunteer committee, what we get up to, maybe you'd like to actually get involved in the committee itself, or maybe you're interested in becoming a BCS member, you'd like to know a bit more about the benefits and what's to gain, you can contact us using our email address on the screen or via our branch webpage. And why not follow us on our socials, our LinkedIn and our X, to keep up to date with our upcoming events. So all that's left for me to say is thanks again to everyone for joining us tonight. Hopefully see you at our next webinar. Good night, everyone.